go learn something about running the model, though. So running the model here, if you run, and you'll notice that there are these controls up here. This one will run the model as quick as you can. Watch this. What just happened? They all became super big. I think it's, I'm not sure. I guess we fit in. What's that? Yeah, no, I don't think they, that's the funny thing. I don't think they died, but it ran it to its end anyway. Alternatively, in running it, I could use times, speed it up by 25 times, by 50 times. And, you know, I'm really interested in why. Sorry? Yeah, I'm just trying to figure out why it is that, oh, okay, I guess after a certain, I'm not sure why it wasn't all black, though. That's the funny thing at the end. In any case, okay, so here we have the state chart describing things. Should we make these rates dependent on their age, then? What do you think? Should we make their chance of developing overweight depending on their age? Okay, so let's do that. In order to do that, let's go to the palette, and let's go drag in a table function. That's what they call a table function. You'll notice that AnyLogic has these various very handy things, table functions, custom distributions, schedules, which can be used to sort of establish nice kind of mappings and draw from custom distributions. Let's make this one overweight or gaining overweight hazard by age. Gaining overweight hazard by age. Now, I know you're humoring me. This strange guy from Canada come. Perhaps you're humoring me out of politeness. But naming is important. Naming is one of the most important tasks you have at hand when you're building a model. If you don't name things well, you're going to leave yourself vulnerable to mistakes on a very easy basis. And you're going to be complicating your life unnecessarily in terms of the amount of work needed to get a model constructed. Turns out with the right names, you'll be able to communicate more effectively to yourself in the future and to others. And it'll make writing those formulas, which have to be written, often it will really clarify what you have to do with those formulas. So naming things clearly, so you can kind of glance at them and know what they're about, is useful. If you just called this table function like its default name, would it work? Yeah, it would still work, but it would be opaque. You'd be looking at a model and you wouldn't know what's there. But this, you actually know something about, okay, this is dealing with a chance of becoming overweight, of gaining overweight by age as age progresses. So it kind of makes it clear what's going on there, what things are in your model, even if some of the details are hidden. So let's go to this thing, gaining overweight by age. Who needs the Dylan help? Okay, gaining overweight by age. Let's go down here and let's open up table data. This allows us to specify for different ages what's the hazard rate for gaining overweight. What's the chance per year for gaining overweight? So, you know, age 0, give me a certain thing. Age 5, there's going to be some chance per year, perhaps, of gaining overweight. We're going to talk about the shortcomings of this in just a minute, of hard coding this, but we're going to reflect on it. So maybe, you know, age 5, there's a, I don't know, there's a 2% chance per year on average, 2% chance per year of gaining weight. Maybe for age 10, and by age 10, a 3% chance by year. By maybe age 20, these don't have to be evenly spaced. Maybe we make it 0.025. You don't have to copy my exact values. I'm just trying to give kind of some sense as how you might put together a function here. You know, into their 40s, maybe it would be 0.04 per year, something like that. Just putting in some numbers here. Up here, 0.05 per year. The hazards of old age and its depredations bring a weight gain for many. Okay, so that's almost certainly off. In any case, I put in some representative values. The point is, this is mapping ages to hazard rates. So when you're a certain age, you have a different hazard to which you're subject in terms of risk of gaining weight per year. Does that make sense, this notion?
It does. Can I ask a question? That's kind of assuming familiarity in a sense.
Yeah.
Like we know that if you're overweight or obese as a child, you've got enough cholesterol.
Right. Exactly. And
that's
exactly a beautiful segue. You've just set it up for me to make my next point. I said I was going to talk about the shortcomings of this. So, and this is my fugue. The theme from yesterday returns. The counterpoint is strong, and we return to the theme of the fugue. So we put this in, and maybe this is very accurate given our current numbers. Maybe we have very detailed data on people's, gaining weight by age from national surveys. In Canada, we have both longitudinal and cross-sectional surveys. In the States, they have the NHANES and the NHIS, et cetera. And I'm sure Canada has an admirable set of surveys. And Canada probably did not, in a fit of pique, cancel its long-form census out of pandering to certain political groups, as Canada has to its aim. Is that not right, Dylan? In any case, the point is, we might have very detailed data about this, and we can put this in, and this model might characterize the current situation okay. The current situation, I put my emphasis on that. But if we want to look forwards, we know there's important drivers for this which are not being captured, right? There's drivers having to do with changing norms involving eating, changing norms involving built environment, changing norms involving early life exposures that are not captured in this data. This data might be very precise right now, but it's looking out the back window in a way because it's assuming the current situation. And we know even looking forward, this will probably be changing. We know the patterns associated with childhood obesity have changed dramatically over the past 50 years, right? And even if you were to have a model that was intricately specified using data from 1960, you'd be whistling in the dark if you plug that data in here because you wouldn't be capturing even today's patterns. And maybe more to the point, if we were to intervene, if we were to think about interventions at the level of the built environment or at the level of the nutritional environment, filling in food deserts, which will be the subject of one of our models. If we start to think about interventions which improved or lessen the likelihood that a child will be exposed in utero to a dysglycemic environment, those things would change all of this. And there's many others that I'm not listing, obviously. If we put in place walking school buses or other policy initiatives, things would be nudged. And by hard coding this, we're not really capturing those effects at all. Now, it's not to say we didn't get some insight. This is the sort of thing you might have in a Markov model, transitions, sort of fixed rate transitions between values. And you could have a certain amount of benefit by asking, well, suppose we could have this risk of becoming overweight. What are the distal implications? And particularly as we're going to be adding diabetes into this model before or after lunch, depending on the timing, and have several state charts. And we might be able to capture those distal implications in a way much richer than we could with a Markov model where we don't have this nice separation into multiple sort of types of concerns. But we still be missing the really big sort of emergent impacts of investments in the built environment or investments in the in the availability of healthy foods in a community, or subsidies, or subsidies for good foods for reserve populations in Canada, for Aboriginal peoples, or what have you. So in short, these numbers, while they may be very precise, they're falsely precise. They're sort of precise in a way that's misleading. We may have sweated them, but they're missing the main game. They're missing sort of the need to examine counterfactuals, which may radically change them. And they may not even hold true for much, for another 5 or 10 years before they start getting really out of whack. So, typically what we do here in a situation is, you might have some, to illustrate how I might approach a problem like this, you might have some studies which have examined, maybe using a survival analysis approach, or in other cases, a recurrent event analysis for different problems, or competing risks in some cases. You might have hazard rates that have been studied in terms of various risk factors, various covariates. Maybe these are things such as early life exposures. Maybe it's factors such as the nature of the physical environment, level of physical activity. And you could put in, a relationship here where you have some baseline hazard, some hazard that's operating, but it's nudged up and down by these various covariates. And that's what I did in that GDM model that I provided to you, is I had sort of a classic formulation like you might get out of a competing risks analysis, where you have some exponent of some betas times various covariates, all times a baseline hazard function, which sort of in the absence of those factors, or it's sort of a reference point. It gets nudged up and down according to these various covariates. So that we could do that. We could have not just one function here of age, but we could have a function of age that's then nudged up and down by life exposures of this individual, their history of this individual, the particular environment of this individual, the ethnic or other characteristics of this individual would nudge these up and down. And that's what I've done in the GDM. But even that is missing some potential. And again, it brings home this issue of model scope, model conceptualization, because there we'd be missing, perhaps we'd be assuming a fixed level of physical activity, and what we actually perhaps are interested in is interventions that affect physical activity. Hence why in that other model, I had physical activity explicitly represented. So then we could see the ripple through effects of physical activity on this gain, take into account some hazard rates, but that are adjusted according to the dynamic, not the fixed, but the dynamic physical activity as captured by those stocks and flows there. So there, you're starting to take into account, you're endogenizing physical activity. You're capturing it in the model, and that allows you to sort of simulate interventions focused on physical activity, but still capture their very material impacts on the risk of weight change over time, or the occurrence of weight change over time. And then in turn, in that other model, in ours soon, on risk of chronic disease outcomes perhaps years later. So there we've endogenized certain factors, and this relationship here, rather than being a fixed mapping between age and hazard rate, instead it will be some baseline mapping and then adjusted up or down according to various covariates in a sort of classic statistical type of fashion. So that was one approach to it that I tried to capture in the GDM model. And just to make it clear what I'm talking about, and I think I can pull it up here pretty quick. In fact, what I'll do is, here I'll do it in Windows land. Okay, so if anyone wants it, I should note I have a lot of example models here that I could give you. These are almost all health focused, and if anyone's really interested in getting dozens of models, just come up and speak with me. Here we are. Here's the GDM one. Let's go to what I did there. You see you'll see how it gets to the model scope. So when we did this, here we went person, and let's go see, here's the pregnancy. You recognize this? It's a little bit more general, but we've got this. Let's look at this risk of going from normal weight to overweight here. You notice what lies behind. Here's this X. I mean, this is, so when you have, say, a competing risks analysis, it's often formulated in this for your various odds ratios involved, and you have various covariates specified. And so here, you notice I have the current age multiplied by an age-specific covariate. So this beta is expressing sort of how much does age end up affecting some hazard function. I actually didn't have, and I probably should have had instead of having this, I could have had this whole thing multiplied by exactly what we have in this other model here. This model. In other words, I could have done. Well, a most unseemly thing. Okay. Sorry. What am I doing? I'm confused. Okay. Here we go. I could have had this sort of function by age as kind of the baseline function, and then I could have multiplied out here, instead of having a line for it here with a covariate, or with a beta, I could have just had all these things here that adjust basically for birth weight, for obesity on the part of this individual. So the birth weight of that individual at birth, incidentally, so their history, aspects of overweight, whether they were exposed in utero, their current level of physical activities, SES status, and I could have multiplied the whole thing by exactly what we see here, by this sort of age-specific hazard rate. And that would have been one approach that we use in other models that would take into account aspects of their current situation, of their history, but also of the impacts of age in terms of, the very material impacts of age in terms of wear and tear on the body, and in terms of gaining weight and going on to obesity. Are those comments helpful? So it's a matter of model scope. It's a matter of model scope, and you could start a model like this. This is obviously a little teaching model, but you could start a model as we are here. But if you want to, if it's important to endogenize things because of the effects of interventions, or because you believe the dynamics for those things are important going forwards, you want to explain some of those dynamics and how they impact things, then broadening this model so that these are not fixed rates but are instead dependent on these factors will give you more reliable results. That's really what it comes, Yeah, so it's a good point. The model will help you think through. If you don't know the nature of the relationship and you want to explore different theories for what that relationship might look like, could it be a big effect, for example, of this? Is that consistent with the data? You could put in a relationship there that's that you put in some rough values and you do a sensitivity analysis and you see how big it impacts the outcomes in which you're really interested. And you may find that this particular component it's not very sensitive to, but this one it is, for example, the assumptions there. So even in the absence of clear data on these things, you could end up doing some amount of significant experimentation and exploration. If it turns out it's very sensitive to these things, it sure puts a priority on doing a survival analysis that might bring out for you the values of some of those betas, for example. And that's what we do in our work. We have the model. We shed light using the model experimentation on what data we need in more detail, and then we will conduct either primary data collection exercises or statistical analysis exercises to try to elicit the parameter values that need to go into that portion of the model. And that's a kind of, again, an iterative learning loop where the model is sort of cluing us in to ways we need to put our efforts to learn most quickly. A lot of models, until that sort of understanding is available, often if this isn't the main a central thing in the model, they'll use very simple assumptions for it. Just be very upfront that they haven't examined, the various drivers for this, and state that as a limitation of the model. And at least you can learn about how other dynamics in the model end up impacting the things that you're interested in, but it won't be a fully comprehensive model of the dynamics in the world. I mean, we're dealing here, and I think there was a hand back there. I'll get to that, but we're dealing here with. I'll be very open, with you about this. We're dealing with a set of really tangled, nasty, messy issues, right? In the obesity area, you have all these different levels of issues, and you'll find some speakers from agent-based modeling background. Michael Wolfson is someone. Do any of you know Michael Wolfson from Canada? Okay, he's probably Canada's most prominent microsimulation model. Well, not probably, he is. And he was absolutely seminal in getting microsimulation used extensively in the Canadian context for all sorts of policy decisions. Many of them health-related, many of them social equity-related. Incredibly bright guy and a close colleague of mine and a friend of mine. He was telling me that I need to go climb the Sydney Harbour Bridge with harnesses on. An area where my wife might differ with his judgment. But in any case, he has a different notion of modeling than I do. And if you hear us both, you'll hear quite different emphases. I emphasize models as learning tools, tools for groups and communities, as attempts to clue us in when our understanding is not consistent with the data so we can learn more quickly. Models as things that large numbers of people, large numbers of investigators or researchers like yourselves can build to good effect, and where we can make use of whatever data we do have to good effect. Michael's view is much more, and I don't think he'd disagree with this characterization. So I think I'm being fairly fair. He's fairly technocratic about it. He says, look, it's all fine. He's an amateur astronomer, and it's all fine that you have folks in their backyards doing amateur astronomy, but we don't expect great advances to come from that. Really, where astronomy gets done is big science. Gets done in the big telescopes in Chile and Mauna Kea and Hawaii and in larger scale installations that demand support budgets annually of tens of millions of dollars. And he says, really, that's where modeling needs to get done. It should get done at StatsCan. It should get done at these big centers which have access to massive amounts of data. And Michael aspires to modeling, which is reflecting this, which is of a different character. I talk a lot about ad hoc models and building suites of models for your research problems that are exploratory, that help you think through issues. Michael's vision of modeling, and it's a good one to hear about, is, the picture is StatsCan builds a model, essentially, of the Canadian demographics and life progression, and it has maybe 50 different diseases represented in it, in that single model, and it's kind of a theory of health in Canada, and then you conduct many analyses using that Uber model, right? It's kind of the one model to rule them all. Michael's not the Dark Lord, but I think Michael's great, but the point is, it's kind of a big science notion. You have one model, and it's tied in with data that we, little people don't have access to, these giant databases at StatsCan, which for privacy reasons cannot be shared. It's got extensive data behind it in terms of likelihood of progression, statistical analyses that have been conducted by, phalanxes of statisticians there. And it's all cross-linked with large-scale survey research, so you can get risk factor information. And it's built by people out there. And then the people who use it benefit from its outputs, but they're not involved in its guts. They're not involved in questioning it. They're not involved in revolving it. Rather, it is something granted to them to see the outputs from this model to guide them. And so when Public Health Agency of Canada wants to use this model, they have to go and ask StatScan, can you run some scenarios for us? And StatScan gives back some results. That's a model that's much more crystal ballish than I'm comfortable with. It's being run by these folks in some back office, and they hand me things, and I don't even fully know what's going on in it. And privately, I know many people who use this model, and there's some grousing, because the people who get those results sometimes don't learn until 2 years later that, you mean the model was assuming this? No way, we can't assume that. That's crazy, when those results are produced, because it's all a little bit black boxish. So that's a different level of modeling, but the folks who, they will, without any sort of fear and in a very ambitious way, go derive relationships with this and create this kind of attempt. They try to create a comprehensive model. Once you've built it, you can do an HPV analysis on it. You can do an analysis of cancer care endpoints. You can do an analysis of cost effectiveness associated with investment in early childhood education or what have you. It's kind of the Uber model characterization of things. And two different types of context for modeling. And one that's, I think it's a worthy alternative view to hear. But, as far as these sort of relationships, they're not fazed by those at all. It's just, we'll just leverage these 20 different cross-linked survey data and longitudinal data we have administratively and data on various health outcomes, and we'll estimate those things. For them, that's kind of something they do routinely. I don't know if those comments are helpful, but it's sort of it's a bit of a glimpse of kind of the diversity of the modeling landscape. Question back there.
Yeah, mine's a practical question.
Yeah.
It's related to the previous example that you used with gestational diabetes. You actually had the not the regression coefficient, but you actually had the equation. So where actually the coefficients held, they held in the table somewhere?
So you can hold them in the table. I mean, here, these coefficients, so there are the covariates here, and there are these which are specific to this person, like their birth weight. This is a parameter for that person. The covariates are sort of here in like this birth weight in grams is just this parameter. Now, after this morning, you have some understanding of what that parameter is. It's a characteristic of that person. These betas are, okay, you really want to see the betas? Yeah. These betas are all specified over here. Those can be plugged in, can plug in a value for this directly and store it in the model, or they can be read in from a database. So you read them, or from a spreadsheet for that matter. If you have the values in a spreadsheet that you want to incorporate, you could at the beginning of the model run, bring those in from certain cells in that spreadsheet and use them here. And that's a kind of common thing. Conversely, the model outputs, well, I showed all graphs, and those are all really good and useful. Typically we output a lot of data too for use in R, for example, for analysis. Yeah.
What you've actually done is you've got individual beta coefficients, and that's being run as part of the simulation. But what you're saying is you don't have to do it that way. You can do it as a table, and so for each individual, you would actually run an equation. How would that work?
No, to be clear, and this may be more detail than I was planning to get into, but these beta coefficients that are here, you're right that they're in person, but they're actually, without dwelling on it, these are things that are common for all people. So in other words, we're assuming that this beta, this impact of age on this transition from normal weight to overweight, this hazard rate for that, that beta is shared by basically all people. So each person will have a different age, right? Each person will have a different age, but the effect of age on the hazard is something that's captured in a coefficient, in this beta coefficient, which is shared across all people, and it could be read in from a database or a spreadsheet. And that's right. I mean, this beta is multiplied by age to capture the effect of age on that hazard. No, it would be. No, absolutely. This would come out of regression that would include all of these different factors. So it would include dummy variable for obesity and overweight and birth weight, and I mean we do this in our work for diabetes. We look at the effects of birth weight correcting for various other covariates, and you get out betas just like this, and the hazard, the appropriate hazards, as you listed it through Cox proportional hazards or whatever analysis, would be framed in just that sort of way over here, where you have the exponent of these betas times the appropriate covariates times some baseline hazard function, which would be often a function of age, for example. So these things would come out of a statistical analysis, typically conducted with survival analysis or competing risk types of techniques. Plugged in. Correct. Okay. Yeah.
I mean, it's just about being really clear what you've done.
Yep.
I mean, that's
yep. Absolutely.
Because if you were actually going to apply it, then you've actually got
to Yeah. Oh, lunch.
I don't have to. Yes, I need lunch.
Okay, fair enough. That's actually that was my break. Okay. Very good. So we're going to continue then after lunch, and we're going to put in a separate interacting state chart for diabetes, where those state charts are not solitudes, they are interacting. We're going to have these individuals be at high risk of diabetes as their weight status progresses. Okay? And that is the job that lies before us after lunch. So eat well, come back energized, and ready for another bout.